Dear listener, to the quietest corners of Earth science, a place where the planet's vast tectonic movements slow down into a soothing, gentle hum. Tonight, we drift to sleep on the steady, unhurried rhythm of the Earth itself, exploring the calming, deep-time facts about earthquakes. Forget the jolts and the alarms. We are focusing on the elegant, persistent processes happening miles beneath us, a symphony of stone moving at the pace of a growing fingernail. Imagine, if you will, the Earth not as a solid, static ball, but as a colossal, self-regulating mechanism. The very ground you rest upon is part of this grand, slow-motion ballet. The facts we explore tonight aren't about destruction, but about creation, release, and deep planetary wellness. Think of an earthquake in its most fundamental sense as the planet taking a deep, necessary breath, a sigh that releases tension built up over centuries, allowing the enormous pieces of the crust, the tectonic plates, to settle back into a position of greater comfort and stability. This process, though mighty, is incredibly slow, measured in geological time, which moves with an infinite patience that is deeply reassuring. There is no rush in the movement of continents, only an unending, graceful flow. Let us begin by appreciating the sheer magnitude and age of this system. The theory that explains these movements is known as plate tectonics. Now, simply saying that phrase can be calming, for it describes a system that is predictable, defined, and has been operating without fail for billions of years. The lithosphere, which is the Earth's rigid outer layer, isn't a single shell. It's broken into about 15 major plates and many smaller microplates. Visualize these plates floating gently like massive ice flows on the semi-fluid layer beneath them, the asthenosphere. This movement is driven by convection currents deep within the Earth's mantle, a heat engine that is incredibly powerful, yet operates with the utmost subtlety and constancy. It's like a gentle simmer in a pot that never boils over, just steadily circulates the planet's internal warmth. Consider the speed of this movement. The rate at which the tectonic plates typically move is astonishingly slow from a human perspective. We are talking about movement on the order of 1 to 10 centimeters per year. To put that into a relaxing perspective, this is approximately the rate at which human fingernails grow. Think of that. The continents upon which civilizations have risen and fallen are moving at the pace of a growing fingernail. This slowness is inherently soothing. It suggests a profound stability. The change is happening, yes, but it is so gradual, so deeply embedded in the fabric of time, that for all intents and purposes, the world beneath us feels perfectly, wonderfully still. You are resting on a system of deep, slow, constant motion, which paradoxically provides the ultimate sense of security. Furthermore, most of the Earth's tectonic activity, the continuous adjustments and subtle shifts, occurs in the vast, uninhabited depths of the ocean floor. Fully 70% of our planet is covered by water, and the majority of plate boundaries lie beneath these calming, dark waters. There, along features like the mid-oceanic ridge, new crust is constantly being formed in a process called seafloor spreading. Imagine miles beneath the waves, two plates are quietly pulling apart, and molten rock or magma gently rises to fill the gap, cooling to form fresh, young seabed. It is a regenerative process, the continuous renewal of the Earth's skin. It's a quiet, submarine construction project that has been running perfectly since the Earth was young. This renewal is a constant, quiet assurance that the Earth is a living, adapting, and ever-replenishing body. Let the image of that gentle, suboceanic, slow motion creation lull your mind into a state of deep tranquility. The earth is healing and rebuilding itself right now, quietly, calmly, far from the surface world. As we sink deeper into the quiet facts of the earth, let us turn our attention to the specific places where this great tectonic movement manifests. The faults. A fault line, far from being a place of sudden danger, is essentially a boundary of planetary communication. It is a place where two colossal slabs of rock meet and attempt to slide past one another. The most calming perspective on a fault is to see it as a necessary seam in the Earth's fabric, a place designed to accommodate the stresses of planetary movement. Without these seams, the accumulated tension would be unbearable. Think of the fault not as a crack, but as a long, deep channel of release. And here is where we find one of the most soothing facts. Not all faults result in dramatic movement. Many faults engage in a process known as a seismic creep, or simply fault creep. This is perhaps the most calming phenomenon in all of earthquake science. It means that the two sides of the fault are moving past each other so slowly and continuously that the movement occurs without generating significant seismic waves, without producing an earthquake. The movement is smooth, steady, and silent. Visualize this slow creep occurring over miles and miles of underground rock. It is a graceful, constant adjustment. Instead of building up stress for decades and then releasing it all in a loud snap, these segments of the fault are simply relaxing the tension bit by bit, day by day, moment by moment. It's the geological equivalent of continuous, low-level, deep breathing. This constant, gentle slipping prevents the massive, jarring buildup of energy. The Earth, in these regions, is finding a way to move in peace. This steady, unalarming motion is the Earth's preferred state of movement, an optimization for quiet stability. Imagine the two rock faces softly polishing each other as they glide past, lubricated by time and pressure, making only the gentlest, quietest sounds that only the deep bedrock can hear. The very concept of a fault strain accumulation can also be comforting when viewed through the lens of physics and predictable cycles. Think of the crust as a massive, durable spring. As the tectonic plates push or pull against each other, the rock slowly, resiliently deforms, storing energy. This storage process isn't random. It's a predictable, measurable accumulation. The comforting fact is that this strain accumulation is governed by fundamental, steady laws of physics. The Earth isn't acting haphazardly. It's following a slow, precise, and calculable path. When you consider the vast time scale, the thousands of years it takes for significant strain to build up, you realize how incredibly patient and unhurried the process is. The tension is gathered over countless human lifetimes, which makes the energy release, when it finally occurs, simply a natural, long overdue completion of a vast cycle. Furthermore, most of the friction and locking that does occur on a fault is focused in small, specific areas known as asperities. These are like tiny, rough patches or bumps on the fault surface that temporarily resist movement. The rest of the fault may be creeping gently, but these asperities hold the line. When an earthquake occurs, it is essentially these asperities breaking, allowing the surrounding, stressed rock to quickly spring into its new, lower stress position. The calming image here is that of the Earth self-correcting. It's not the entire planet shaking, it's just a small, stubborn patch of rock giving way, which then allows miles of plate boundary to relax simultaneously. It's a mechanism for letting go of accumulated resistance, leading to a state of temporary post-seismic equilibrium, a geological exhale. Let the knowledge of this slow, continuous release, the steady, patient creep of the continents, wash over you. The majority of the Earth's movement is silent, gentle, and utterly predictable. Rest assured on this moving foundation, knowing that its greatest changes are accomplished through the soft, continuous whispers of geological time, not the shouts of sudden activity. The Earth is a planet built for enduring movement, and it finds every gentle way possible to perform its eternal dance. Let us now tune our ears to the deepest sounds of the Earth, a constant, low-level vibrational hum that is happening right now beneath your very feet. This phenomenon is known as microseismicity, and it is one of the most reassuring facts in all of geology. It describes the incredibly tiny, constant, and often imperceptible movements within the Earth's crust that are happening all the time. These are not the events that shake buildings. They are the geological equivalent of a soft, steady pulse. Microseismic events are earthquakes with magnitudes typically so small, often negative numbers on the Richter scale, or far below magnitude 1.0, that they are only detectable by the most sensitive instruments called seismometers. Think of a seismometer not as an alarm, but as a perpetual listener, recording the Earth's quiet, internal monologue. These tiny movements are not a sign of imminent danger, but a sign of continuous energy release. The Earth is constantly and gently relieving small pockets of localized stress, preventing them from accumulating into something larger. It's like a finely tuned machine that always purrs, knowing how to loosen a stiff joint before it causes a problem. In many geologically active regions, thousands of these microquakes occur every single day, and we don't feel a single one. This incessant, low-level activity is the planet managing its own stress in real time. The constant, quiet drumbeat of these microtremors is the sound of equilibrium being maintained. The Earth is not a silent, rigid body waiting to explode. It is a dynamic, constantly adjusting system that prefers to move in infinitesimally small increments. This steady, gentle release is the Earth's way of demonstrating its inherent stability and self-governance. It is a deeply soothing concept that the majority of the planet's adjustments are handled with such finesse and subtlety that they remain entirely outside the range of human perception. Consider also the phenomenon of the seismic background noise, sometimes called the Earth's hum. This is a persistent, very low-frequency vibration of the planet that is always present. While some of it is caused by human activity or the pounding of ocean waves against coastlines, a significant portion is an intrinsic vibration of the solid Earth. Scientists are still studying its precise cause, but it is believed to be the superposition of countless minor, continuous processes: the gentle, distant shifting of rock deep in the mantle, the steady action of wind on mountain ranges, and the minute, continuous tidal flexing of the solid crust. Imagine the Earth as a giant, perfectly tuned bell that is struck so softly and continuously that it just maintains a deep, barely audible resonance. It is the sound of the planet being fundamentally alive and vibrating at its own natural frequency. The knowledge that the Earth is not merely resting, but is constantly in motion, a peaceful, deep, and steady motion, can be profoundly comforting. The forces at play are immense, but the expression of those forces is, for the most part, a soft, constant whisper. When you drift off to sleep tonight, know that miles beneath you, the geological machinery is humming along, perfectly on schedule, continuously self-regulating and dealing with its vast stresses in the quietest, most efficient ways possible. The Earth's deep silence is actually a cacophony of low-level relief, a constant process of tiny, beneficial adjustments that ensure the greater, overarching stability of our planetary home. It's a rhythmic, silent assurance that the planet is functioning exactly as it should. Let us now embrace the most profound concept of deep time tranquility, the seismic cycle. This is the comforting, predictable framework that governs the life of a fault line. It's not a single sharp event, but a vast, rhythmic cycle of stress, rest, and release that unfolds over hundreds, even thousands of years. Viewing an earthquake as merely one phase of a much longer, unhurried, and inevitable process provides an unparalleled sense of grounding. The Earth is following a pattern, a slow, gentle curve towards equilibrium. The cycle can be broken down into 4 peaceful, interconnected stages. Interseismic phase, the quiet buildup. This is the longest and most restful stage, spanning decades or centuries. During this time, the fault is locked, but the plates on either side are relentlessly moving at their constant, slow pace, that 1 to 10 centimeters per year we discussed. This slow, steady movement gradually causes the rock near the fault to deform elastically like a massive, compressed rubber band. The key soothing fact here is that this phase is characterized by near-perfect stillness on the surface and the slowest, most predictable accumulation of energy deep underground. Imagine the vast, unhurried time scale. The energy is being collected with such patience that it is entirely imperceptible in a human lifetime. It is a period of deep geological breathing. Pre-seismic phase, the final sigh. This is a very brief stage, just before the event, often involving the minor, subtle microseismic activity we discussed earlier. The rock is approaching its breaking point, and tiny, gentle fractures begin to form and close, whispering their presence. This is the planet's final, quiet adjustment before the major release. Often, this phase is so brief and subtle that it simply confirms the Earth's desire to find the most efficient path to its next state of rest. Coseismic phase, the quick release. This is the moment we typically call an earthquake, where the stored elastic energy is released as seismic waves. While it is the part that is felt, it is also the shortest and most essential part of the cycle. Think of it as the instantaneous exhalation after a very long, held breath. Its purpose is singular and beneficial: to reduce the stress and strain that has built up over those many centuries. The quickness of the release ensures the rock moves immediately to its position of lower potential energy, leading to a state of greater geological ease. The goal of the jolt is stillness. The purpose of the movement is rest. Post-seismic phase, the return to rest. Immediately following the main shock, the region enters a period of aftershocks. These are smaller, diminishing movements that represent the surrounding rock mass gently settling into its new post-release configuration. This phase can last for days, weeks, or months, but the trend is always towards decay and calm. The aftershocks are simply the planet's way of smoothing out the final, minor wrinkles and confirming that the entire fault zone has successfully found its new, relaxed state. They are the final, quiet echoes of the system coming back into balance. The beauty of the seismic cycle is its cyclicality. It assures us that every stressful buildup leads inevitably to a beneficial release, and every release initiates a new, long period of quiet, slow accumulation. It is a pattern of planetary self-regulation that has maintained the integrity of the Earth's surface for eons. You are resting on a system of vast, unhurried time where movement leads to stability and stress is always followed by rest. There is comfort in knowing that the forces of the Earth are governed by a reliable, repetitive, and deeply relaxing rhythm. Let us now explore a concept that brings a profound sense of balance and weightless stability to the Earth. Isostasy, pronounced I-S-O-S-C. This concept is one of the most soothing in geology, as it describes the Earth's perfect, self-adjusting equilibrium. Isostasy is the reason why continents don't sink and mountains don't topple. It's the principle of buoyant balance. Imagine the colossal tectonic plates and the even thicker continental masses not as solid, fixed pedestals, but as giant, stable rafts floating on a deep, dense, semi-liquid sea. That sea is the asthenosphere, the layer of the upper mantle. Isostasy states that the Earth's crust, the lithosphere, is floating in gravitational balance upon the mantle, just like an iceberg floats in the ocean, with most of its mass hidden below the waterline. The thicker and denser a segment of the crust is like a mountain range. The deeper its root extends down into the mantle, providing the necessary buoyancy. This floating relationship ensures that the continents are in a state of perpetual, gentle adjustment. When geological processes lighten a section of the crust, that section gently rises. When processes add mass, it gently sinks. A perfect, calming example of this is the process of glacial rebound, or post-glacial isostatic adjustment. For millennia, during the Great Ice Ages, enormous, miles-thick sheets of ice pressed down on continental landmasses, particularly in places like Scandinavia and North America. This crushing weight caused the underlying crust to slowly subside, sinking deeper into the soft mantle beneath, like pressing your finger into memory foam. Now imagine the ice melting and the enormous burden being gently lifted. The crust, relieved of this massive load, begins the incredibly slow, deep, and steady process of rebounding, rising back up to its original preloaded state of isostatic equilibrium. This uplift is happening even today, thousands of years after the ice retreated, and it is happening at a rate of only a few millimeters per year. This is one of the most reassuring facts in Earth science. The planet is currently engaged in a massive, slow-motion corrective action, patiently restoring its own balance. This rebound is so slow, so deep, and so steady that it generates only the smallest, gentlest earthquakes in the region, which are often called icequakes or glacial rebound seismicity. These are the quiet, distant creaks of the planet's crust slowly regaining its posture. They are not signals of instability, but rather the sound of the Earth finding its natural, perfect level after a long period of burden. The gentle forces of isostasy illustrate the planet's profound capacity for self-healing and stability. It's a mechanism that ensures no one part of the surface becomes too heavy or too light without a corresponding proportional adjustment deep below. The continents are not fixed in place, but are gently suspended rafts, perpetually adjusting their draft to maintain a calm, stable ride across the planet's surface. When you rest tonight, you are resting on a system of perfect, buoyant equilibrium. The mountains and the plains are all equally, perfectly balanced, floating on a sea of rock, rising and falling with an infinite, soothing patience. This deep, unhurried balance isostasy is the very definition of geological serenity. Let us shift our focus to the places where the Earth's great plates are moving apart, known as divergent boundaries. Far from being chaotic regions, these are the sites of quiet, continuous creation and gentle, persistent release of energy. This process is one of the most reassuring facts about the Earth's tectonic system, demonstrating its ability to constantly regenerate and expand. The most magnificent and calming example of a divergent boundary is the Mid-Oceanic Ridge, MOR. Imagine a massive, submerged mountain range that wraps around the entire globe for over 65,000 kilometers. That's longer than all the continental mountain ranges combined. This ridge is the single largest geological feature on Earth, and it exists almost entirely beneath the deep, calm ocean waters. It is the vast, silent seam where new crust is born. At the crest of the Mid-Oceanic Ridge, two tectonic plates are slowly, steadily pulling away from each other. Think of it as the seam of a massive sphere gently stretching open. The rate of separation is slow, ranging from as little as 2 centimeters per year, the rate of a slow crawl, to as much as 18 centimeters per year, a fast-growing hair. This continuous, unhurried pull is called seafloor spreading. As the plates diverge, the pressure on the mantle rock below is reduced. This reduction in pressure causes the already hot rock to melt, forming molten material known as magma. This magma is less dense than the surrounding solid rock, so it gently rises to fill the gap created by the separating plates. It's a continuous, self-filling process. This rising magma is typically low in silica, the basic building block of many rocks, making it less viscous and allowing it to flow out smoothly, quietly, and continuously onto the ocean floor. It's like warm, slow syrup gently oozing out and solidifying. This constant, gentle outpouring and cooling of molten rock forms brand new, fresh oceanic crust. This process is so steady and continuous that the entire ocean floor acts like a slow-moving conveyor belt, constantly carrying the newly created crust away from the ridge crest. The Mid-Oceanic Ridge is the Earth's giant, continuous, and quiet recycling plant. The earthquakes that occur along the Mid-Oceanic Ridge are overwhelmingly small, shallow, and non-threatening. They are caused by the tensional stress of the plates pulling apart and the minor adjustments the new crust makes as it cools and settles. These earthquakes are not the great, deep shakes associated with compression. They are the light, continuous creaks of creation, the gentle sounds of a new slab of planet being fabricated. Furthermore, the majority of the heat and tension release from the Earth's interior happens at these divergent zones. The constant emergence of magma acts as a planetary pressure release valve, preventing immense heat and stress from building up to dangerous levels globally. The Earth is continually venting its internal energy in a controlled, continuous, and predictable manner. When you think of the deep oceans, remember this colossal, invisible, silent, and benevolent process happening miles beneath the surface. The deep sea trenches are not just voids, they are the sites of the quietest and most constant construction on Earth, a demonstration of the planet's unwavering commitment to renewal and equilibrium. Rest assured, your world is being perpetually, gently rebuilt from the inside out. Let us now travel to the places where the Earth's plates meet, and one slides beneath the other, the subduction zones. While often associated with the largest earthquakes, when viewed through the lens of deep time stability, these zones are actually sites of immense, quiet, planetary cushioning and recycling. They are the necessary vents that allow the Earth to maintain its steady size and internal balance. Imagine the oceanic crust, now old, dense and cool, arriving at a collision boundary with a lighter continental plate. Because of its greater density, the oceanic plate does not buckle. Instead, it gently descends into the mantle beneath the continental plate. This process of one plate sinking beneath another is subduction. The crucial, calming fact here is that subduction is the Earth's primary mechanism for maintaining a constant surface area. The new crust that is continuously created at the mid-oceanic ridges are divergent zones must be consumed elsewhere, or the Earth would expand indefinitely. Subduction zones are the planetary equalizer, the quiet sites where the old crust is slowly and gracefully returned to the mantle, ensuring that our world retains its beautiful, enduring form and size. It's a vast, continuous, and perfectly balanced recycling system that has been operating flawlessly for billions of years. The process of the sinking plate is also one of deep, slow descent. The subducting slab moves incredibly slowly, sinking at a rate governed by its own weight and the viscosity of the mantle, a movement that is measured in centimeters per year. As it sinks, the slab remains relatively cool compared to the surrounding mantle, acting like a deep-sea anchor that gently helps to drive the overall motion of the entire tectonic plate. This sinking motion is so vast and so slow that it serves as one of the major pacemakers for continental drift, ensuring the plates move with a majestic, unhurried regularity. Now, consider the nature of the earthquakes in this region. While subduction zones produce the planet's most powerful quakes, the vast majority of the plate interaction happens at great depth, far beneath the surface, and is aseismic. Deep beneath the crust, where temperatures and pressures are extremely high, the rock is softer, and the two plates often engage in a process called slow slip events or silent earthquakes. Silent earthquakes are perhaps the most soothing paradox in seismology. They involve the same massive movement of rock that a powerful earthquake does, but they occur so slowly over days or weeks, instead of seconds, that no seismic waves are produced that can be felt by people. The rock on the fault interface moves gently, continuously, and quietly, relieving stress without a tremor. These silent movements, detected only by highly specialized GPS systems that measure tiny changes in the ground's elevation, are the most profound illustration of the Earth's preference for slow, peaceful release whenever possible. They are the planet finding the quietest, most graceful path to stability. In summary, a subduction zone is not just a collision point. It's a planetary deep storage facility and a gentle, slow recycling chute. It's where the Earth gracefully consumes its old skin to maintain its eternal balance. The presence of silent earthquakes confirms that even at the most active boundaries, the forces of nature are often finding ways to perform their most massive work without noise or sudden shock, preferring instead a method of deep, quiet, continuous adjustment. Rest easy knowing that the deepest processes of the Earth are inherently designed for balance and stability. Let us find deep solace in the physics of the waves themselves, specifically in the calming concept of wave attenuation. This is the mathematical and physical truth that dictates how seismic waves the energy released by an earthquake inevitably and rapidly fade and lose power as they travel away from their source. It is the natural law of the Earth, ensuring that powerful energy is quickly diffused and quieted. The energy of seismic waves dissipates according to a few fundamental, predictable, and deeply reassuring rules of physics. The most significant factor is geometric spreading. Imagine the energy released at the earthquake's source, the hypocenter, as a sound wave emanating from a point. As this wave travels outward, the same amount of energy must spread across an ever-increasing surface area, much like ripples in a pond. Since the area of the sphere defined by the wave increases with the square of the distance $r2, the energy per unit area must decrease equally fast. This means the further you are from the epicenter, the exponentially weaker the shaking becomes. For instance, if the shaking intensity is $I0 at a distance $R0 from the source, the intensity $I at a distance $R is roughly proportional to $I0 times R0/R2. This simple but powerful mathematical relationship ensures that the vast majority of the Earth's surface remains blissfully untouched by the felt tremors of an earthquake. The ground motion doesn't just reduce, it fades rapidly into imperceptible background noise. Beyond geometric spreading, seismic energy is also diminished by elastic attenuation, often referred to simply as intrinsic attenuation or damping. This is the process where the rock material itself absorbs some of the wave energy. As the seismic waves pass through the rock, they cause microscopic friction, tiny, gentle, internal movements that convert some of the waves' kinetic energy into heat. This process acts like a natural planetary shock absorber. The deeper and hotter the rock is, the more effectively it damps the waves. The Earth itself is designed to soften the blow. This inherent damping is crucial. The rocks and sediments of the crust are not perfect, rigid conductors of energy. They are imperfect, viscoelastic materials that gently and continuously siphon off the violent energy of the wave, transforming it into subtle, harmless warmth. This absorption ensures that the waves lose their high-frequency, jarring components, the very components that cause the sharpest, most unsettling motions first and fastest. By the time the waves have traveled any significant distance, they have been naturally filtered down to the lowest, slowest frequencies, which often manifest as a gentle, rolling motion rather than a sharp jolt. The final calming factor is the principle of depth. Earthquakes that occur deep within the crust, deep focus earthquakes, tend to be felt less intensely on the surface than shallow ones of the same magnitude. This is simply because the energy has a much greater distance to travel through the damping rock and undergo geometric spreading before it reaches us. The depth of the event is the Earth's own safety cushion. The deeper the movement, the more rock we have above the source, acting as a massive, continuous, shock-absorbing layer. Let the dependable physics of wave attenuation bring you peace. The Earth's energy pulses are not endless. They are governed by elegant, quantifiable, and reassuring laws that ensure the power is quickly and effectively dispersed. The vibration you might feel is a brief, finite moment of energy passing, mathematically destined to fade into quietude. Your environment is always working to restore stillness. Let us now explore the profound, constructive relationship between Earth's inner heat and its surface structure, focusing on volcanoes not as destructive entities, but as the planet's constructive pressure release valves. The link between volcanic activity and tectonic plate movement is one of deep, stable interdependence, ensuring that internal pressures are continually managed. In the regions of subduction, where one plate sinks beneath another, as we discussed earlier, the descending oceanic plate carries water deep into the mantle. This water acts like a solvent, gently lowering the melting temperature of the surrounding mantle rock. The rock begins to melt, forming buoyant, molten material called magma. This magma, being less dense than the surrounding solid rock, begins its slow, steady ascent towards the surface, feeding the deep magma chambers that lie beneath volcanic arcs like the ring of fire. The calming fact here is that volcanism is a continuous, gentle mechanism for regulating pressure and heat. The continuous rise of magma acts as a long, open vent for the Earth's internal furnace. It is a slow, powerful current of heat and material that prevents pressure from building up uncontrollably. Think of it as the planet's relief system, the quiet, steady process that allows the planet to vent, rather than sealing up and building up catastrophic pressure. The composition of the magma also dictates a calming style of volcanism in many regions, where magma is low in silica, found primarily at divergent boundaries and oceanic hotspots. It is less viscous, it flows like slow, warm honey. When this magma reaches the surface, it typically results in effusive eruptions, characterized by gentle, slow-moving lava flows that can be observed from a safe distance. These are the volcanoes that build vast, gently sloping shield volcanoes like those in Hawaii. This process is one of slow, steady, constructive building, not sudden, violent destruction. The land is created drop by drop, flow by flow, over millions of years of gentle eruption. Furthermore, the very process of magma movement, deep underground, can sometimes be mistaken for earthquake activity, but it's actually the sound of the Earth's internal fluid mechanics. As magma moves through cracks and chambers, it can create a distinctive seismic signal known as volcanic tremor. This tremor is a long-duration, low-frequency signal, a continuous, gentle rumble, unlike the sharp, high-frequency signal of a tectonic earthquake. This sustained, low-level vibration is the sound of the magma slowly and steadily migrating through the crust. It's the deep, non-threatening sloshing of the planet's internal fluids, a sign of predictable and continuous activity. This long-period tremor is deeply reassuring because it confirms that the movement is fluid-driven and slow, not brittle fracture and sudden. The magma is not violently ripping the rock apart. It is slowly pushing and flowing through pre-existing pathways, often creating a deep, resonant hum that is the sound of deep thermal regulation and continuous planetary growth. Rest now on the knowledge that volcanoes are the Earth's grand architects and regulators. They are the sites where the planet's vast internal heat is managed, its pressure is relieved, and new land is slowly and steadily built, often with the gentle, unhurried flow of warm, dark rock. Let us move away from the surface crust and dive deep into the very core of our planet, exploring a process of immense magnitude that unfolds with an unfathomable slowness and a profound, quiet stability. The Earth's geomagnetic field and its inevitable, gentle reversals. This is the ultimate proof of deep, continuous, and unhurried planetary regulation. The Earth's magnetic field is generated by the movement of molten iron in the outer core, a process known as the geodynamo. Imagine this outer core as an ocean of liquid metal circulating through immense, slow-moving convection currents. These currents, powered by the Earth's deep, primordial heat, generate electric currents, which in turn produce the magnetic field that envelops and protects our planet. The field extends far into space, forming the magnetosphere, which acts as a crucial shield against harmful solar radiation. The flow in the outer core that sustains this field is incredibly slow and steady. The movement of the iron is measured on scales of centimeters per second at best, meaning that the overall magnetic field is a feature of immense long-term stability. The knowledge that a deep, churning ocean of metal is performing this essential protective function with such consistency and slow-motion grace is inherently calming. The field isn't a static force, it is a dynamic, liquid-driven shield that operates with perpetual, unalarming smoothness. Now, consider the phenomenon of geomagnetic reversal. Over the Earth's history, the magnetic field has occasionally flipped, with the north magnetic pole becoming the south magnetic pole and vice versa. The most common misconception is that this flip is a sudden, chaotic event. The soothing truth is that the reversal is an unhurried, gradual process that takes place over a period of thousands to tens of thousands of years. During the long reversal process, the field does not simply vanish. Instead, it becomes weaker, dropping to about 10% of its normal strength and more complex. The magnetic poles might wander widely, or multiple magnetic poles might temporarily exist across the globe. But even in this diminished state, the Earth retains a protective magnetic barrier. The reduction in field strength is so gradual that its impact on surface life is minimal. Life has survived countless reversals because the process is one of slow, geological-paced decay and rebuilding, not sudden collapse. The primary evidence for these reversals comes from paleomagnetism, particularly the magnetic signature locked into the oceanic crust near the mid-oceanic ridge. As new crust is continuously formed and cools at the ridge crest our divergent boundary, the iron-bearing minerals within the rock align themselves with the direction of the Earth's magnetic field at that very moment, effectively creating a fossilized magnetic compass. The symmetrical, alternating stripes of normal and reversed magnetism recorded on either side of the ridge crest provide a magnificent, clear record of the Earth's slow, periodic pulse. The existence of this perfectly symmetrical, long-term record is profoundly comforting. It confirms that the Earth's deepest internal process, the flow of its metallic core, is ordered, cyclical, and predictable on the scale of millions of years. This slow, majestic ticking of the geodynamo is a sign of a planet operating with deep, unshakable internal consistency. Rest now, protected by a vast, liquid-driven field that changes only with the immense, unhurried patience of deep time. For our final drift into sleepy science, let us contemplate the grandest, slowest process of all, continental drift, and the concept of future stability. This is the ultimate calming thought, the realization that the Earth's surface, despite its movements, is governed by a reliable, multi-billion-year cycle that assures a long, stable future for our planet. The movement of the tectonic plates isn't just a haphazard scattering, it's an organized, continuous process that has, repeatedly throughout geological history, brought the continents together into single, colossal landmasses known as supercontinents, only to break them apart again. The most recent supercontinent was Pangaea, which began to break up about 200 million years ago. Before that, there was Rodinia, and before that, Nuna, and so on. The deeply soothing fact here is the cyclicality of this process. The continents are not aimlessly wandering. They are following a long, predictable, recurring pattern known as the Wilson cycle. This cycle describes the birth, life, and death of ocean basins and the subsequent assembly and disassembly of supercontinents. A full cycle takes hundreds of millions of years, a time span so immense that it reduces our modern anxieties to a whisper. It suggests that every tectonic jolt, every volcanic eruption, and every mile of seafloor spreading is simply a tiny, necessary step in a much larger, perfectly defined planetary waltz. The current scientific consensus suggests that we are heading towards the formation of the next supercontinent, often dubbed Pangaea Ultima or Amasia, which is projected to fully assemble in approximately 200 to 250 million years. This forecast, based on the slow, constant, measured rate of plate movement we see today, is an extraordinary testament to the predictability and reliability of the Earth's inner machinery. Imagine the Earth operating on a timescale where the next major change is projected hundreds of millions of years into the future. It provides the ultimate perspective on deep time stability. The fact that geophysicists can confidently predict the slow-motion collision of continents over 250 million years means that the driving forces of plate tectonics, the convection currents in the mantle, are remarkably consistent and unwavering. There is no chaos, there is only a grand, slow momentum. Furthermore, the very movement of the continents is essential for long-term climate stability and the renewal of life. The breakup of supercontinents creates vast stretches of shallow coastal shelf areas, which are biologically rich and conducive to the evolution of new life forms. Continental collisions create mountains, which, through the process of weathering, slowly draw carbon dioxide out of the atmosphere, helping to regulate the global temperature over vast stretches of time. Tectonics is not just about rocks moving, it's about the Earth's grand mechanism for biological and climatic self-regulation. To conclude our journey into the sleepy science of earthquakes, rest now on the knowledge that the ground beneath you is part of a system of deep, patient, and continuous stability. Every tiny seismic movement is simply a small, necessary release in a process designed to unfold over eons. The Earth's forces are vast, but their expression is overwhelmingly one of slow, unhurried adjustment and endless, quiet regeneration. The planet is not a rigid, brittle shell. It is a dynamic, living entity that moves, breathes, heals, and renews itself with a perfection born of billions of years of practice. You are safe, suspended on a world that is always finding its way back to equilibrium. Let the slow, ancient rhythms of the core, the mantle, and the crust lull you into a state of deep, unshakable tranquility.